Hi, everybody. Thank you so much for joining us today. I hope you're all safe and doing well. My name is Ilana Krasner. I'm a product marketing manager at Spot. I'm joining you all from Tel Aviv, Israel, so it's evening for me, but good morning and good afternoon to those of you who are a little further west. Today, we are joined by Wybov Pernick. He's the head of engineering at GumGum. GumGum is an AI company that has really seen incredible growth. And as Wybov will share, that growth can come with some higher operating costs. And for GumGum, it was a cloud bill for Amazon, EC2 instances where they were seeing a lot of high costs in operating in the cloud. And so that's what brings us here today. And that's where Spot, now Spot by NetApp, comes in. So Wybov is going to share with us how GumGum was able to achieve significant savings on their cloud infrastructure. Significant savings is about $500,000 a year. So I'm excited that he's here to share with us how GumGum was able to achieve that. Before I pass it off to him, I do want to introduce Spot by NetApp to those of you who are joining us for the first time and don't know who we are. Spot was recently acquired by NetApp in July. We're really excited about the opportunities that working with NetApp is going to bring us to help us really help our customers make the most of what the cloud has to offer, to help them leverage the full capabilities of the cloud and make sure that our customers are continuously improving in their cloud operations, both in terms of cost savings and in efficiency, and their ability to more seamlessly manage infrastructure. And so we're doing that by leading through what we call cloud ops. So Melissa, if you can move on to the next slide. We'll talk a little bit about what cloud ops is. So we're in a new phase of the cloud era, I think, where many organizations have some, if not all, of their applications and systems running in the cloud. Now we're really talking about accelerating and optimizing those processes and tools and services. And that's the concept of cloud ops, bringing together the different components that really do make up a well-oiled cloud machine, and also determine how you will continuously optimize and improve in those operations. So Spot really fits into the first two categories that you see here, DevOps and FinOps, and helping companies to overcome many of the challenges that they're facing in managing and balancing some core pieces of their infrastructure from availability, capacity, performance, and cost. So at Spot, we've got a core set of offerings that address the challenges that many of you are probably facing when it comes to managing your cloud infrastructure. We leverage machine learning, advanced analytics to deliver products that intelligently and automatically handle the tasks of managing infrastructure for you. So we are effectively relieving much of the burden from ops teams and giving budget holders a lot more control over their cloud spending. So the way our products work is through data, analytics, and automation. Those determine and deploy the ideal mix of compute resources that you need to make sure that you have the availability and the scale and can scale efficiently while you're minimizing costs, and you're leveraging all the different compute pricing models that the cloud has to offer. So our applications are our offerings are really for a slew of different use cases. So whether you're running containerized applications, big data workloads, web apps, test environments, etc., we can really help you. We're constantly adding new features and capabilities. So I do just want to mention that we'll have some new features and updates coming out soon in the next few weeks. So for our cloud analyzer, we are going to soon have that available for users of GCP and Azure. We'll be rolling out a new UI to our Ocean console in the next few weeks, and Elastic Group will also soon support Azure's new Spot VMs. Please visit our website, spot.io, for more information. You can check out Cloud Analyzer. That's our free cloud analytics tool. You just connect your cloud account and you can see how much you'll save on compute with just a few simple steps and clicks. So with that short intro to Spot, I'm really excited to pass it off to Wybov he's going to take it from here. And so, Wybib, can't wait to hear the story.
Hi, everybody. Thank you, Alana. So my name is Vaibhav Puranik. I have been working with GumGum for last 12 years. I started as a Java programmer at a contractor to Johnson Space Center in Houston. And after that, I have been through various different software companies. And for the last 12 years, I have been with GumGum. I was kind of like a second employee to the GumGum, engineering employee to the GumGum, at GumGum. And then after that, I just, as the company grew, I grew with it, and I had to chance to work on various different technologies such as Java, AWS, big data processing, mainly high traffic web services, and big data processing is my forte, so to speak. And then I want to begin with also introducing my company, GumGum, to you. GumGum is an AI company, but really in artificial intelligence, we have a niche. And so we do artificial intelligence that is connected with advertising. Advertising is a big part of our business, essentially. And all of our AI offerings are sort of designed for advertising. So what you see on the screen right now are some of the examples of what we do. For example, on the left-hand side, you can see we have this unique offering where we display an ad on top of an image at the bottom of an image. We call it in-image ads. We kind of came up with this whole concept of in-image ads in 2008. And then other one is a similar thing, the second one, where the advertisement is on the bottom of the page instead of an ad, instead of an image. What you see with the cats is our customized offering using our computer vision capabilities. So those hats that you see on top of cats are actually not part of the picture. They have been placed on their heads by our AI engine, our computer vision engine. And the ad that you see at the bottom, there's no letter in the room. So there'll be more text that'll come up later, essentially. I haven't pasted the animated version of it, but the cats sort of get placed on, so the hats get placed on cat, and then animation sort of goes on. So we can do that kind of stuff. We can actually identify objects in images, and then we can play around with those objects to make advertising much more interactive. Then I want to tell you more about our next offering, which is essentially the engine behind our AI. It's called Verity. And what really it does, it provides contextual intelligence, and not just to GumGum, but to the whole world, because this offering is actually available as an API to the rest of the world. So what it does, it takes a web page and analyzes a lot of stuff around that web page, on that web page. So it tries to find out what are the important keywords on the page. It tries to find out what are the it tries to classify the page. Is this a sports page, or is this a fashion page, or is this a finance page? So classifying the page into categories, right? And another thing it does, it also looks for threats on the page. Is there anything dangerous, bad, not safe for work content on the page? For example, is there any sexuality, or is there any guns or violence? Is there any disaster? Is there any drugs and alcohol, right? It tries to find all of those things, because advertisers do not want to associate, do not want to show their ads on these pages. And that is why we not only can decide what ad is more appropriate for this page, but we can also decide using our Verity contextual intelligence engine that no ad is appropriate for this page because this page has something bad on it, right? And so the brand safety is very, very big part of our contextual intelligence engine. Yeah, I mean that's about our AI part of it, and then in the future next discussion, I'll exactly explain where we use Spartans in AI and as well as other part of the advertising. So let's before I go to using how we use Spot instances, right? I want to tell you what was the problem that we were set out to solve way back in 2017, right? And what you're seeing on the screen right now is our infrastructure cost, and essentially your AWS bill for the first half of the or more than half of the first 10 months of 2017. And you can see that in January we were much smaller, and look how as the company started growing, it started getting more traffic. It just started growing exponentially, right? I mean, our infrastructure bill was like 3 or 4 times higher than January in October. In October's bill was way higher than January. And these numbers are pretty big. I mean, I haven't put in the numbers there, but those numbers in October are approaching $1 million so per month, which is, I think, crazy, right? For our size of company. So that was the problem. I mean, the main problem is the rate of infrastructure cost growth is in line with your rate of growth of your profits, or or your revenue, right? That is the main problem. And sometimes what happens is when you're adding a lot of new features, right? The rate of growth of infrastructure cost might be higher than your rate of growth of revenue. And so it became very apparent to us that we need to do something about it. We need to actually address this. We need to lower our cloud costs, right? So we set out to that. We set out on that mission. How can we lower our cloud costs, right? So next slide, I'll try to present an obvious solution. Anybody who uses AWS, knows this solution, that if you have AWS, the one way, sure shot way to reduce your cost is essentially reserved your instances, right? And there are a lot of different kinds of reservation offerings available, right? And they will definitely reduce your cost by to a large extent. I mean, they can reduce your cost up to like 30 to 35%. So if you go to next slide, Melissa, I can show you what is a problem with just relying on the reservation, right? So on the left-hand side, you see a curve or a graph, right? That's essentially going half. Now, if those of you are watching stock market right now knows that that's what a bull run actually is, right? It is that the stock market keeps going to the newer highs, and then it comes back down for temporarily, and then it goes to a newer high, right? And that's exactly what our growth was in terms of our traffic, in terms of our infrastructure cost, and also in terms of our revenue, sort of, right? Or no, because in advertising, the business is cyclical, and what that means is the traffic grows from January to December, and then the next January the traffic goes down. Again, it starts increasing, and it goes to the lower heights in the next year, right? Again, it goes down, and it keeps doing that all the time, right? So one of the problem it poses is that you cannot really come up with a good algorithm to sort of reserve number of instances, because what if the growth, there is no good way to predict what that growth is going to be, right? So what if you predict certain amount of growth and you grow less than that, right? And then you have all these reservations, which are commitments made for the entire year. That is the least amount of period you can commit for, right? And then you're going to waste this money, right? And so that's why, in a growing environment or a rapidly changing environment, it becomes very difficult to actually predict what should be your reservations, right? Another thing that reservation poses is, in order to get the best benefit out of reservation, you need to actually commit to a particular instance type. Now, you can nowadays do reservations without committing to any particular instance type, right? But the reservations, the percentage of cost savings achieved in those cases, it's significantly less. For example, like the new savings plans, right? They only can save you up to 15 to 20%, right? Versus a reservation which is tied to an instance family can save you up to 35%, right? Which are tied to a particular region, right? So really, if you know what you're doing, if you know if your workloads are going to remain static, if you really know what's going to happen in the future, that your services are not going to change, the instance requirements are not going to change, then you can tie down to your reservation and you can save about 30% of your cost, right? And then you'll be fine. But what if you don't know that? What if AWS is constantly launching new instance families, and each of their newer instance families are cheaper than their older instance families, right? So how do we actually make sure that we can keep upgrading our instances, right? At the same time, not locking us down to at the same time, get the benefit of the cost savings and not lock us down to a particular instance type. And that's why we were looking for different kinds of solutions. So in the next slide, what I'm going to show is what are some of the other different things what we try to do to reduce cost, right? So first of all, AWS has Spot Fleet, which essentially allows you to use Spot instances in a fleet or like sort of an auto scaling manner. And then there's an open source library called auto spotting too, which allows you to sort of a layer on top of AWS Spot, which allows you to sort of use a lot of Spot features a little bit easier. Okay, but none of these solutions appeal to us that much because, especially in 2017, Spot Fleet was definitely not a mature product, and I'm not 100% sure whether it does all the stuff that Spot does right now. And auto spotting is also, we have tried it and we're still not comfortable completely handing over all of our workloads to auto spotting, even after 3 years of using Spot or Spot.io, right? So what we came down to is our requirements. So if you go to the next slide, we'll know we wanted to. These are the requirements we sort of jotted down, that whatever the service we are going to use in order to evaluate that service to pass our muster, they need to have a guaranteed capacity. They need to make sure that if we say we need 10 instances for this particular service, then it must provide 10 instances to us, right? Then it shouldn't take time to implement the whole solution. Shouldn't take any management work from our side, right? I didn't mention that there, but that's a very, very important thing, because we were a very small company and we cannot afford to have like the one person just taking care of this system that is managing our spot bidding. We wanted we are 100% AWS, so we wanted something that's 100% native to AWS, compatible with AWS. We wanted something too easy to use, right? Programmers shouldn't sweat on it, or their DevOps engineers shouldn't sweat on it, yeah. And of course, it should not cost a lot. So our savings should be significant, right? And at that point, if you go to the next slide, Melissa, the important sort of piece of software in our architecture that we were looking to save cost was our ad server. Just to give you an idea of how big is our ad server software is. So this software is essentially a Java application run on Tomcat, and it runs on hundreds of servers across 4 different geographic regions of AWS. Those are Virginia, Oregon, Ireland, and Tokyo, which is Japan. And it gets 30 million requests per minute hitting to the load balancer. And these are like pretty hefty instances. These are C5 9x large instances. So you can understand, like these are pretty big instances, and there's a lot of compute intensive work that these instances are doing in order to serve those ads. And the just cost of those instances, running those instances, is north of $100,000 per month. So it's a massive workload, and we identified that as the use case, that if we do something for a reduction of cost, this is the first thing where we're going to try our thing, because that's our biggest cost. Any significant cost improvement can be achieved by going to doing something there, right? So then what happened next is we had this engineer who who was our sort of heading ad server team at that point. He actually once came to my office and he said, Vaibhav, I have an idea. And in pretty soon, in like next 2 or 3 days, you're going to see our AWS bill go down significantly in ad server. And I was a little bit scared because, ad server is the critical software. It gives us like, it gives us our revenue, right? Most of our revenue. So I immediately asked him, what are you trying to do? You make sure, you tell me everything you're trying to do, because we can't mess with ad server, Uh, and he said, I found this company. And at that point, the name of the company was different. Right now it's Spot.io by NetApp, but at that point it was Spotins tab. And he said, I found this company called Spotins, and it is a small company in Israel. And they just make like using Spot instances really easy. And I think I can implement this in like 2 or 3 days. And they'll guide me implement this. And let's just do this. And I was first like scared. So I'm like, well, can I talk to them before even like, before we jump to them? And then he arranged a call with me. And in that call, I had this hunch that I think these people know what they're doing. So I allowed this guy, Mario, who was an engineer, like, okay, go ahead and implement this. And in my mind, I'm thinking, okay, if he's asking 3 days, he's probably going to 2 or 3 days. He's probably going to take 7 to 15 days, because I'm a seasoned manager. I know how engineers give their estimates, right? And that's what I thought. And Melissa, if you go to the next slide. Eh, he actually came back to me in 3 days and said, it's done. And I sat down with him and I went to our AWS bill, and I was shocked. I was literally shocked. And what I'm going to do is I'm going to actually give you like a concrete numbers in later slide before how much exact savings we achieved and that's after paying Spot or Spot.io's fees at that point. So I was amazed. And if you go to the next slide, these were some of the very cool features that they had that sort of blew us away at that point, which is so they have this concept of cluster orientation, and that means that you can choose what are you focusing on. Are you focusing on availability, or are you focusing on sort of cost? Do you want the cheapest? Like, is it okay to disrupt your service but always get the maximum benefit and only use Spot? Versus do a balanced strategy where whenever spots are not available, use on demand, but make sure there's no downtime, that kind of stuff. And I think we ended up using the balanced strategy. I don't remember exactly what we used at that point, but we keep switching that based on the time and season, all that stuff. So there was that, and there was draining timeout, which is they would give us warning that Spot is going to take away this instance. And I think Spotfleet also gives you that warning, just to be fair. AWS gives you that warning too. I think 2 minutes where, all right, I'm going to take this instance away because the Spot market has changed now. And then so whatever work you need to do, if there are files on this instance that you need to save, then do that thing. And then this service that Spot.io was smart enough to actually take use of our existing reservations, because we actually had reservations in place right at that point. And so we wanted to make sure that they use those reservations first, and then whatever is on demand, they try to replace that capacity by Spot. And they actually did that out of the gate. We didn't have to like do anything special. They were doing that in 2017. They're doing it now. And of course, fallback on demand, fallback on demand, I would say. Or what it means is if you don't have Spot instances available because of the market situation, or the cost of Spots become higher than the on-demand instances, right? Then just use on-demand instances, right? Just make sure my service doesn't get disrupted, right? And another cool thing that actually was not available to us at that point, which Spot.io gave us, was having heterogeneous cluster, right? It means that you can actually have different kinds of instances, right? So you can try to bid on C5 9XLs, or you can try to also bid on C5 9D and whatever, C5 D 9XLs, right? These are similar ones, but a little bit slightly different based on, and there are also the C5N 9XLs, right? So you can actually choose all of those instances, and Spot will try to bid and see whichever are cheaper, and then they'll just use it before trying to on demand. And that was actually pretty amazing for us. So I'm not 100% sure whether Spot allows, like the AWS's native Spot allows you to do that right now or not. But in 2017, that was a good feature for us. So all these features was amazing. I mean, we are like, I and Mario and our other team members, we're sitting in our like GumGum offices, and we're just saying, that's exactly what I want. I mean, what happened is after I was like amazed with all of this, I actually like tabulated. I made a spreadsheet to figure out like, okay, how much money am I saving right now per month? Because I didn't want to conclude just by having 2 days of data, because I wanted to see results consistently day over day, correct? And so I waited for I literally went and compiled numbers for 3 months after this implementation. And I populated this spreadsheet that's actually in front of you, right? And September is the month in which we sort of implemented that strategy partially. So September is not a full month implementation, but October is a full month, November is a full month. And I think that you don't see Spot Ends fees because they were doing a trial period at that time, and I think they waived some fees. And after that, if you the key metric you need to really focus on here is the hourly rate, right? We were paying about 91 cents or and I think on October also we were running a partial load. I'm not 100% sure. We hadn't switched completely. But see the difference between September and October and November. In November, our hourly rate went to almost 59 cents from 91 cents. So you can see that that's like 40 to 45% of savings right there, right? And you can see the amount of money that we are saving even after, that's phenomenal. I mean, it's like $60,000 per month, right? And you multiply $60,000 by 12, right? It's way over $700,000. The reason I say 500,000 is because initial months are going to be cheaper, January, February, March. But so I'm discounting a little bit, okay. But I mean, that's the power, right? I mean, that's where I said now I'm committed to Spotinst or Spot.io, because I actually evaluated for 3 months, and numbers told me that yes, it's totally worth it. Even after paying them, it's like way more worth it than yeah. Then we started like talking back to them and started asking them like, hey, what else can we do? Like, do you have other products? Like, can we save more money somewhere? What can we do? And so then they said, well, actually, in fact, what happened initially, we requested a feature with them. So this main feature that we used, right, it was called elastic groups, right? And so instead of having our auto scaling group in AWS, so elastic group is kind of similar concept. It's kind of their Spot instance auto scaling group, and then you can have all the configurations related to auto scaling group in that elastic group. And so we started managing our ad server through elastic group instead of AWS's native auto scaling group, right? And then deployment was a big problem for us too. So they actually like provided us a feature where you could do, it's called Spot Roll, which essentially allows us to do blue-green deployment. And at that point, we were not doing blue-green deployments. So in the next slide, I can show you how we were deploying at that point, right? What we were deploying at that point were, let's say you have 100 instances running in one region, right? What we would do is we would take 10% of those outs, replace them with another 10%, right? And then we keep doing that we keep replacing 10% of the capacity until all 100 instances are replaced. And then we would do the same thing across 4 regions, right? So just imagine how much time it'll take, right, to do this. And then when you're taking 10% of the capacity out for even for a movement, right, you're reducing the capacity for a while. And at that point, we were not sure whether we should just add extra capacity, but I think we figured out that later that it was okay to do that. But so our deployment was a laborious process that used to have latency spikes involved, and it was slow. And then Spotinstance gave us this blue-green deployment feature where we would go to the Spotinstance website and just say hit a button, and it will just completely like just create like entire 100 sort of node cluster, and then you just swap in. Essentially, you just take that cluster in and replace it in, and then there's many advantages of that, right? These are a lot of advantages of blue-green. I mean, you probably have used it in the work environment, but if there are errors in the new software that you're deploying, then you're going to find out offline, not online, right? Because you're creating that entire cluster already out on the side, right? And then you're just putting that entire 100 nodes cluster in your deployment, right? So that's the feature that they provided, and that was amazing. Our deployment just sped up by a lot. So that was another instance. But really, lately, if you go to the next slide, what we're in love with is their product called Ocean. So actually, before I go there, the Elastic Group is a product that we just started loving, right? And it spread through our organization very rapidly. And then where we immediately jumped on is all of our AI workloads, right? So we are strong in 2 different areas of AI. One is natural language processing, another is computer vision, and we have to use both of them because our service actually takes not just analyzes pages, but it also analyzes videos and images on the page as well. And so we can actually tell you holistic, we can tell you like a whole picture about each page, right? So that's what we started using in all AI workloads, and G4 is our main sort of AWS's GPU instance, right? Is our main sort of bread and butter. So we are running hundreds of GPU instances, literally. So we essentially switched all of that using Elastic Group, and all of that is currently running on Elastic Group. So yeah, so if you go to the next slide, yeah, so the next product that we are really trying to adopt right now in a big way at GumGum is this Ocean, right? And they actually launched it, I don't know, maybe a year or a couple of years ago, but we are a little bit slow because Elastic Group is fantastic, it's working fine, right? So it's kind of slower for us and we have to migrate like this massive clusters, right, from one technology to another technology. So it takes us a little bit time to adapt to the newest, latest and greatest, right? But Ocean really, I mean, in line with their motto to sort of make using Spot instances really easier, right? Because, and it's mainly a Kubernetes-centric product, though I cannot say that it's only used for Kubernetes because it works with ECS2, which is not Kubernetes, essentially. So it works with different orchestration services, right? So what it really does is in Kubernetes, you have the workers and then you have a control plane, right? So it really makes running those workers, right, your workloads really easy. So it provides you all these tools and infrastructure to make running those workers extremely easy. And here are some of the services. Here are some of the interesting things that they do, the Ocean does, right? Which we are actually making use of right now. One feature we love is right sizing, right? And what it does is it compares the CPU and memory request of your pods to their actual consumption in production. And based off the historical data, it provides recommendation what should be the CPU and memory allocated to this particular pod. So you can see this graph from our, in this case, it's actually recommending much lower CPU, and I think this is CPU. Yeah, this is CPU, yeah. It's recommending much lower CPU for this particular pod, right? Now, I think I'm not 100% sure the GPU loads are supported for right sizing. They are supported for Ocean, but I don't think they're supported on just the right sizing feature, but they're supported everywhere else. And another thing, next thing is one thing happens is when you move to a containerized workload, right? You lose a lot of insight into cost a lot of times, because what happens is now you're running these clusters and on those clusters, you have multiple workloads running, right? It's like a pool of instances, and there are multiple container workloads running. And it could be like 10 different workloads running on the same pool of instances, right? So the whole old strategy of tracking your cost, which is you are tagging instances automatically, and then going to Cost Explorer and looking at your costs, doesn't work anymore, because it's all one pool of instance, and then you have all these containers running in clusters, right? So that Ocean does solve that problem, because you can actually figure out exactly how much money is spent on this pod cluster, right? You can manage all of that using Ocean Controller, and you can see that it's showing how much a specific particular software called Ad Builder in our ecosystem is actually costing us, and it's giving you compute cost and storage cost both, and then it's giving you total cost, right? And it's a small workload, that's why you're seeing a really small cost, but I think it's fantastic. I mean, you can get, because we watch our cost really, really, almost like every day. So it's important for us to get those reporting when you move to containerized workloads. And really, it does the same thing that Elastic Group does. It allows you to run heterogeneous spot clusters, right? And spot clusters, I mean, it allows you to run your workload on spot clusters. That's what it's made of, right? Which is, so it lowers your cost and allows you to, again, same benefit as Elastic Group, you can have all these different kinds of instances mixed together, and it'll just know how to balance all of them out. So it's perfect. It's amazing. So if we go to the next slide, where are we using Ocean right now, right? So in our advertising department, we are using Ocean. We started using Ocean in a big way right now. I think we have moved all of our web applications to Ocean. We haven't moved our ad service to Ocean yet, but AI workloads is the next thing, next frontier, right? Verity, where right now we are completely on Elastic Group, but the next thing that we really need to do is move our AI workloads to Ocean. Yeah, and then if you go to the next slide, there is a couple of interesting things I want to talk about here, which is Spot.io is really making a strong case to run your stateful workloads in on Spot instances. Now, some people might think, oh, that's crazy. Like the Spot instance can be taken away anytime, and you might actually lose all that state. But actually, it's pretty compelling argument. And if you understand, and we are actually using these features in production right now, right? If you understand what are some of the features that they've enabled, you'll realize how compelling the argument is, right? So the one feature they provide is data volume persistency, right? Meaning you have your EBS volumes, right? And what they make sure that if your instance goes down because it was taken away, the instance has EBS volume. When a next instance comes up, it could be another Spot instance, right? The EBS volume gets automatically attached to that Spot instance. So in that case, you actually didn't lose any data, right? You just had a momentary disruption, right? But you did not lose your data, because your data was on EBS volume, and that EBS volume got reattached to the thing. So that's actually a pretty powerful feature. And go to the next, another feature that they provide is private IP persistence, right? And that means, again, they can preserve your private IP. If the instance goes away, the next instance coming up will have the same private IP, right? And that's phenomenal, because some of the services like Cassandra require you to actually have the same private IP. the software otherwise get confused, and it is very important for a lot of these services to understand that this new node is actually the same node that went down momentarily, right? In order for them to recognize that, it is important that the private IP remains the same, right? And that's why this is a very, very important feature, which is private IP persistence. It'll make sure that the IP remains the same, right? And if you go to the next slide, what's interesting is, so the best candidates for these kind of things is Kafka, ScyllaDB, which is essentially Cassandra, right? Or Druid. These are like some of the stateful services we use, right? These are databases, or or message queues where the data gets persisted, sort of. What's interesting about this stateful feature is, let's say you're scared of your Spot instances going away, and you actually don't think you don't want to use Spot instances, but you want to use on-demand instances. But even on-demand instances will go down once in a while, right? Because the hardware goes bad, underlying hardware goes bad, or something happens. This happens to us all the time. We're running thousands of instances, right? It happens all the time, right? So what if we use those stateful features of private IP persistent and data volume persistence with on-demand instances, right? You can do that. Nobody's preventing you to do that, right? I mean, and you don't pay anything for that. It's completely free, because the way Spot.io charges you is it charges you by actually looking at the difference between the Spot cost and on-demand cost, right? Of course, I'm not their spokesperson, so I don't know how their model has evolved, but at least that's what I understand, right? So if you don't save any money because you're using on-demand instances, then you don't pay anything. So you get to actually use those features for free. And there are some loads at GumGum where we are not 100% comfortable going to Spot instances, but we use those features because it just makes sense to us. It just makes our engineers' life much easier whenever that instance goes down, even if it's once a year, right? It just makes our life much easier. And if you go to the next slide, this is really the compelling argument that they're making. And everybody has to just experience it firsthand by going to their own console. For our ad server group, right, you can actually see the average lifetime of an instance on Spot platform. Now, this is critical because we are all under impression without data that, oh, Spot instances can go away anytime. And, Spot instances can simply, like, it's a matter of few hours. That's all. A Spot instance will probably last a few hours, right? Look at this data that an average life of Spot instance is 24 days, 24 or 25 days in certain availability zones and certain instance combination. This is not across everywhere, okay? So one interesting thing about Spot.io is it gives you all this data, right? So it can tell you that if you want to use C5 9x large, then on US East 1B and US East 1D, the average life is 25 days, right? So that means those are the best easies for us to use, right? Compared to a combination of US East 1B and C5 and 9x large, right? So if it's actually going down once per month, then it might not be that bad, right? It might be a strong case to actually using Spot for stateful services. And that is the reason. And again, you should not rely on my data because my US East 1B might not be your US East 1B in AWS. So you just have to know that. Like, you have to run it on your workloads, and then it'll tell you data for your stuff. And then based on that, you should decide what is good for you. Let me just quickly summarize, right? What are some of the things that we like about Spot? And I'm going to also dwell on what are some of the things we don't like about Spot, right? But I think really where they shine is excellent support, just constant communication. Our team is constantly talking via Slack. And even new features we ask them, sometimes if it's feasible for them, gets implemented pretty quickly. It's just extremely easy to use. I think that's their number one, because it reduces the barrier to entry, right? Yeah, I mean, those are just, and even when like for example, I remember that when G4 instances were introduced, like everybody's within 24 hours of Amazon launching them and making them generally available, G4 were available for picking up. So I think that's just fantastic. I mean, we love that. And if you go to some things that we don't like, the next slide, uh, they're the small things you can call our pet peeves. There are some very cool features that are not well documented, so you have to like sort through documentation, really go through it to actually get to those features, understand them. So I wish that documentation was better, but you know, and then minor bugs with the Terraform modules. I don't know exactly what bugs are, but this is what my engineers keep telling me all the time. So. And there is noisy alerting, because I think what happens is we have signed up our main Spot accounts is using a mailing list, and then a bunch of us are in that part of the mailing list. And then Spot sends all of those alerts to that mailing list. But really, we are a bigger organization. We are like 45 engineers, and there are like many teams. Almost every team uses Spot.io, and everybody's workload is different. So really, we want like more enterprise features where um, every sort of each team should have its own mailing list, and then just for this particular elastic group, this team should get notified, versus that other elastic group, other team should get notified. So those are some really enterprise features. I think they're still implementing those features. So that alerting is a little bit noisy, because it's one mailing list, goes to everybody. So everybody, all 45 engineers get this same thing, that, oh, this particular group, elastic group, has whatever things on it, changes were made to it. But again, most of the other people might not be interested in that alerts. So that those are some of the things we don't like with Spot. But other than that, right? Really, I mean, the main value that it brings to you is it makes using Spot instances really easy. And I think that's the main value proposition, and that's the only reason you should go to Spot, or decide whether that's what you want or not. And based on that, I mean, and it just makes it just reduces the barrier to entry and makes our life way easier to just maintain the Spot instances going forward in production workload. So I think that is very important to know. Like if you want to use Spot, and if you want to make your life easier, then just go to Spot.io and pay a little bit of money to them, and you can sleep peacefully. That's pretty much it.
Well, thank you so much, Vaibhav, and we appreciate the feedback. Luckily, I'm here, so I'll escalate. I'll trickle that up, some of your feedback for our documentation, which we're actively also improving as well. We really appreciate you joining us tonight. I do have a question for you to specifically around your containers and what you were doing before Ocean to handle auto scaling or scaling your infrastructure. Were you sort of using the open source cluster autoscaler, or doing something a little DIY? Like, how are you handling auto scaling in your clusters before Ocean came in to make your life a lot easier?
I don't think we were using anything, but what I'm going to do is I'm going to let Corey Gale, who is our DevOps manager, answer that question, because I think he's just more knowledgeable in that than me. So Corey, you want to answer that question?
Yeah, sure. So we have two different situations. The first one is with ECS. So when we first deployed an ECS, we did not use any Spot integrations. So in that case, we were basically managing those workers ourselves. So we had to put together an auto scaling group. We had to put together some CloudWatch metrics and some scaling policies to scale in and out. And we also had to develop a lot of glue to make sure the applications stayed online during those scaling in and out processes. So that's what we did in ECS with Kubernetes, though, and specifically EKS for us. We actually tried with a couple off-the-shelf solutions like COPS. We're not successful with that. So yeah, to answer the question, it was done manually. And for Kubernetes, the only auto-scaling that we were happy with was the Ocean provided one. Yeah. Does that answer your question? I guess we don't see that.
It did. Thank you so much for answering that, Corey. And I think that we're, close to the end of our time with you guys tonight, or today. It's night for me. And so I want to say thank you to Wabav again. Our contact information is here. You can follow Spot on Twitter, LinkedIn, and you can, like we said, visit us at spot.io. And please reach out to us if you have any questions. We will send out a recording of today's webinar. You should get that in the next few days. And again, if you have any other questions, please let us know. Thank you all so much for joining us today. That's it. Thank you, guys.